Yeah, he works. We're going to start off with example number 1. Somebody read the instructions on example number 1, please, because we got to read them to know what they're asking us to do. John?
Solve each inequality and check the solution. Graph the solution on a number line.
Okay, so you got to solve each inequality. The checking part we're going to do in class. You can do it mentally. And then graph the solution on a number line. I'll make it a very simple graph. I will not make this complicated and long so that it takes up a lot of time. But example number 1, we're going to look at example 1a. And that says to solve 7x plus 29 is greater than 15. Why is this called an inequality? Elizabeth? Yep, it has an inequality symbol. Why is this not called an equation then? Because it doesn't have an equal sign. Okay. Or we could say it doesn't only have an equal sign. So it doesn't, we're going to call it a inequality here. Okay, what are we trying to do with this inequality? We're trying to solve it, which means we're trying to find what does x equal. So looking at this right here, I don't know what x equals, but I do know what's happening to x, and then I have to undo that. So what do I have to do here first to solve for x? Bella? Good. Subtract 29 from both sides. Please put the subtraction symbol so you know, oh, I'm taking away from both sides. That gets that 29 canceled. 7x is greater than what? Negative 14. Yeah, 15 minus 29 is negative 14. I hope you guys know that. What's my last step in this problem to solve for x? Marissa? Yes, I'm going to divide both sides by 7. And I'm left with x is greater than negative 2. That is my solution for this inequality. X is greater than negative 2. How many solutions are there?
Infinite.
Infinite number. Because how many numbers are greater than negative 2?
A lot.
Okay, I need you to show me all of them. And how do you do that? You do a graph. So here's my graph. This is how I want you to do it. Please pay attention. Because it's funny. Like I'll say a specific thing. Don't do this. And I thought I had everyone's attention, but someone doesn't. Or I say, do this. And I thought I had everyone's attention, but then someone doesn't do that. Okay, so watch. You're start with your number line. You're just going to put 1 point in the middle, and it's going to be the number of your solution, negative 2. You don't have to go 1 above it or 1 below it. Just that number. I hope I got everyone. I have everyone's attention. Then what kind of circle should go on negative 2? Do you guys remember?
Open.
Why should it be open, not closed? Because it's either one or the other, but why not closed? Callie? Yeah, it doesn't have the equal to symbol, so you don't shade it in. And then this is what you need to do. You need to darken the line to the right or to the left. Which one in this case? Sophie?
To the right.
To the right, why?
Because the greater than symbol, the arrow is pointing to the right.
Okay, it's pointing to the right. And what numbers are greater than negative 2? Any number that's to the right of it. So you shade that in. And then you have this here, your solution. That's all I want to see. These two are part of your solution. Okay? Does that make sense? But it said to check your solution. I'm like, you mean I got to check all the infinite number of solutions out there?
No, just 1.
Yeah, I'm going to do 2. And the reason I'll do 2 is to help you out to see, maybe you got this, but you graphed it wrong. How do you figure that out? But did I have a question, Jensen?
Yeah, didn't we actually already do this?
Yeah, we did. We solved for inequalities, but not multi-step inequalities. And we solved multi-step equations, but not multi-step inequalities. So yeah, this is like review, right? But there is one key difference. Other than the graph and the way you write your solution, there's one big thing. If you do this to both sides of an inequality, you have to do...
Change this sign.
Yeah, do you guys remember what the rule is? If I multiply or divide both sides by a negative, what do I do to that inequality symbol? It has to switch directions. It automatically has to change directions. Okay, so we'll get to that in just a moment. Yes, sir?
So let's say it was 7x times 15. So then you do divide by 15 on both sides. Or it was times negative 15. is divided by negative 15 on each side, and so then you switch the sign, and then let's say it was negative x, and then so negative 7x, so then you would divide by negative 7x.
And
Switch it again?
again.
Okay.
Yeah, you're going back and forth if that's the case. Yes, ma'am?
Did you already divide by 7 in the lower part, so do you have to change it?
No, in this problem, it did not change because I never divided or multiplied by a negative. He was giving me like a hypothetical, like if you had it. Okay, but I'm going to check this. My solution was x is greater than negative 2, and my graph was open circle line going to the right. Okay, what you do is just pick a simple number that should be part of the solution. So can anyone give me a number that should be a part of the solution?
Negative 1.
Braden? 1. Okay, 1 is over here. Should that be correct? Like, should that be part of it? So the original expression was, or inequality was, so does 1 work? If it does, it is part of my solution. So 7 times 1 plus 29 is greater than 15. What's 7 times 1? Plus 29?
36.
Is 36 greater than 15?
Yes.
That checks. So that's how I check it. Okay, nice, I got it. But sometimes maybe the number should have been positive 2. So I also check a number to the left. So what's a simple number to the left?
1 or negative,
1.
negative 3.
Negative 3 would be 1. Okay, so I'm going to check that into this. 7 times negative 3 plus 29 is greater than 15. What's 7 times negative 3? Negative 21 plus 29? 8?
No, 8, sorry.
8? Is 8 greater than 15? No. So do you see why I would not have shaded the left side? So you can check it. You can check both sides. You shaded the correct side because it works. You did not shade this left side because it doesn't work. It does not work. Do you guys get that? So you can check, and you can do this mentally. You don't have to write it up. Okay, let's go to B. And B is where it starts getting, again, complicated like we had in the past. 13 minus 6n is less than or equal to 49 minus 2n. Oh. I'm going to use the same 4 steps that I used in the multi-step equations. So does anyone remember from yesterday what the first step was? It was to, yes, Emma Grace? Eliminate parentheses. Are there any parentheses here to eliminate? Nope, I'm done with that. Second step. Starts with the word, or go ahead. Add like terms. Can I add these two together in any way? No. Nope. Can I add these two together in any way? Nope. Step 2 is done. Step 3.
Send the variable to one side.
Send the variable to one side or the other, or isolate the variable. Yeah. So your choices are add 6n to both sides or add 2n to both sides. What do you want?
2n.
Okay. And is it because you really like the n on the left?
Yes.
Okay, that's fine. I really like n to be positive, but it's your choice. So if you add 2n to both sides, you're going to get 13. What's negative 6n plus 2n? I think I heard negative 4n, right? Negative 6n plus 2n is negative 4n. Less than or equal to 49. Yeah, that got canceled out. Plus 0, you could have said. We haven't done that yet because we're going to actually do that next. Okay, does anyone see how we added 2n to both sides and we got this inequality? You guys okay with that? The tricky part, I think, is right here. Mr. A, isn't it 6n plus 2n is 8n? But it's a negative 6n. You got to think of it that way, algebraically. Yes, ma'am?
Negative 6n plus 2n equals negative 4n, but you put 13 minus 4n. Wouldn't it be 13 minus negative 4n?
I see what you're saying. So the 13 is good, right? We're not confused about the 13. It's right here. Okay, what's negative 6n plus 2n? Negative 4n. So what I'm saying here is 13 plus negative 4n. Wasn't it 13 plus negative 6n up here, technically, algebraically? So I didn't change wow, I don't know, it's not reading it, but I didn't change that it's addition between 13, whatever else is next. So it should be this right here, not minus negative 4n. Because technically, 13 minus negative 4n is 13 plus 4n. And that's not what we're... It's 13 plus negative 4n, not 13 plus 4n. And I know, that's a lot, right? That's a lot to kind of look at. But you know what's cool? Can I give you some encouragement on this subject? That, you know, the positives and negatives, adding and subtracting? It won't get to you, hopefully. Well, I hope it won't. What's encouraging is that a lot of you are getting this, which is great. Like I'm encouraged by that as a teacher, and some of you are not. But then little by little, I start seeing you guys get it more and more and more. And I don't expect you to fully get it right now. It's not there yet, but it will get there soon. And then next year when we're doing this stuff, I don't even talk about it. You're just like, yeah, got it, keep going. It'll get there, but not always right away. So don't feel bad. It takes time to really understand that. Okay, what's happening to 4n? My last step is to solve, because I got the n to one side or the other. So what's happening to n? Think carefully. What's happening to n? By?
Negative 4.
Yeah, negative 4. And?
Added by 13.
Added by 13. And if you didn't fully get that, how do you get rid of this 13 anyway?
You subtract.
Yeah, I subtract, because what's 13 plus 13? 26. But what's 13 minus 13? Cancel out, but what I do one side, I do to the other. So what am I left with on the left side? Negative 4n. Negative 4n is less than or equal to 36. Uh-oh. What do we do next? Well, just like we normally do it, Callie.
You divide negative 4 on both sides.
Great.
And then what if you switch?
What? Why?
Because you're dividing a negative on both sides.
Very nicely put. I have to change the direction of the inequality sign because I divided by a negative on both sides. So I get n is greater than or equal to negative 9. N is greater than or equal to negative 9. That's the big difference. Do you have to worry about that with the equations? No, because there's no switching of the equal sign. All right, how do I graph this? Can someone kind of walk me through it because I need you to know it? Okay, give me one step at a time. First step, Bella, go ahead.
Draw a line.
Good, draw a line. Second step, Callie.
Draw a line in the middle.
A tick. Third step, John.
Draw an arrow draw a close circle on the line.
What should I do?
Should we draw the
What's missing here?
number first?
The number first. There you go. Next, fourth step. Bella?
Draw a closed circle.
Close circle. Fifth step, Callie.
Draw your arrow going
To the right.
and you gotta
Sixth step. No?
Celebrate.
Fill in the line. Okay. In the simple 6 steps, you can graph this equation. Okay. Obviously, you guys know each step was very easy, but this is what it should look like. Closed circle on negative 9 with an arrow going to the right. Okay, can we check this real quickly?
Yes.
Let's just check it to see if ours is correct. So can you give me a number that's greater than or equal to negative 9? Jack?
Negative 1.
Negative 1. Okay, and by the way, pick easy numbers. You could pick negative 7. Fine, but just pick a number. Negative 1 is good. Okay, this is where you need to think. What's negative 6 times negative 1? Positive 6. 13 plus 6? 13 plus 6? 19. All right, so this is what I have so far. What's negative 2 times negative 1? Positive 2. What's 49 plus 2? Okay, is 19 less than or equal to 51? Works. You could do 0. That makes it nice. What's 13 minus 0? 13. I'll write it down here. And what's 49 minus 0? Is 13 less than or equal to 49? Mm-hmm. So how many solutions do I have? Okay. We all know that it'd be like negative 8, negative 7, negative 6, all the way into infinity. What other types of numbers should work?
Decimals.
Decimals, what other numbers? Fractions. So technically, like -8.5 should work. And it's complicated on the math, but it works. -8.2593 with a 7 after it. It's got to work, right? Or a 1 after it. And a 0, 1 as well. Negative pi. Okay. It tastes just as good as positive pi. Okay, here are your solutions. I want you guys to make sure you guys are getting this. So, on page 353, I want you to give me the solution and graph number 5. Number 5. On page 353, number 5. It's almost like you knew I was going to ask that.
I did it before because I just wanted to do more problems.
Oh, look at that. Imagine that. You want to get better at it? So you do more that doesn't make sense to me. Yeah, if you want to get better at something, keep doing it. Yes, ma'am. You may. Tell me what to do. And you guys keep working out and she'll work out.
Subtract 2 from each side.
Good. What do I get?
You get 21 on the right side. And you get 3x is greater than or equal to or
Less than or equal to? Uh-huh.
And then you divide 3 on both sides. And you get x on the left side. And then you get 7 on the side greater than.
Yeah, and this is the top. You read it. X is less than or equal to 7. Mm-hmm. And then what's your graph look like?
A line with the tick in the middle, the 7 in the middle, and close, and a line or a arrow pointing to the left.
Whenever I feel like you do anything that solution can involve 0, it's easiest to check with 0.
Yes, if you want to check with 0, you can. Yep. Because here, 0 should work. And sometimes, like if this were, let's say, -7, 0 should not work. And you can check that. You can check things that work and do not work. Yes, Sydney?
When you put your arrow on like both sides, but not like the line, but like the arrow, because it's like going that way.
I see what you're saying. So shouldn't you put the arrowhead? I've seen that, and I'm okay as long as this arrow looks different from that arrow. Like if you do that, it's okay. But don't shade both of them in or make them look the same because it looks like, oh, it's going both ways, which is a solution. Sometimes it goes both ways, so don't make it look like that. So that's okay. Yep.
I get some water.
Can you wait just a few minutes? Thank you. Yes, ma'am?
So if it's all numbers, if it's all numbers, you just.
Yeah, you would just shade everything in. And you don't even have to, like all numbers would be, usually you start with 0 and you just go. You could just do that. Yeah, and that is, do we have solutions that are all numbers?
Yes.
Okay. Questions on this one? I'm going to give you the toughest one I've ever given on this part today. This hour.
What is it?
I don't know if you guys can handle it, but I will trust you. Number. Actually, I'm looking for it as we speak. Number. Oh, this one is a tough one. Number 28. 353, number 28. No. Try it. Just try it. You either get it utterly wrong or correct or something in between. Hopefully, if you're showing your work, we can find out what happened. Yeah, 28 is a tough one. Step 1. What do you do? I'm just walking it through just to help those who are maybe stuck. Step 1, you would do what? Yeah, eliminate the. Okay, so parentheses are up there, but how do you eliminate? Do you just cross them out? What number's in front of this parenthesis? -1. Do you remember there's a -1 there? If not, now it's there. Okay, ready? What's -1 times c?
-1c.
Good, -1c. -1c. What's -1 times -5? +5. Then I still have this 8c, and I have the c plus 17. I think that should be enough to give you a boost if you didn't get that.
Wait, you never said that there could be a 1 in front of the parentheses. I thought it was just in front of variable.
If I didn't say it, thankfully I won't give you this problem, this type. But yeah, whenever you have a set of parentheses, and I'll just make this one up. Is there a number in front? If it's not written, yeah, it's always a 1. Or it could be a -1, depending on the sign. And then you use distributive property with those. So sorry if I didn't say. I thought I did, but I don't think I did. Which is okay. It's good practice. So do you guys notice that 1 is everywhere? I mean, it's everywhere. Even if it's not written, it is everywhere. Like it's all over that place. All over that problem. Okay, what would be my next step? Step 2 would be to add or subtract or combine like terms. And are there like terms on the left side?
Yes.
Yep, the 8c and the -1c give me 7c, and then plus 5 is greater than c plus 17. Great. Okay, step 3, get the variable to one side or the other. Your choice. Jack?
Subtract 1c.
Good. There's a 1c here, so if I subtract 1c from both sides, I get 6c plus 5 is greater than 17. Then what do? Step 4. Step 4 is to solve. Good, solve. How do I solve for c? John? Subtract 5 from each side. I get 6c is greater than 12. What do I do lastly? Jack? Divide both sides by 6. C is greater than 2. Look at that. All that complicated. C is greater than 2. How do I graph it?
Let's do 10.
Listen, was that a tough problem? Did I say it was a tough problem? Okay, so I hope I didn't say, hey, this is an easy one, do it. It is a hard one, but is it possible? Maybe right now it seems impossible or very hard, but you'll get it. Okay, you won't be doing that on the homework. Not this specific type. The hardest one you're going to get is probably like number 25 and 27. You guys see those? Yeah, the 25 is tough just because it has decimals, but you can deal with decimals. And then 27 has some of that element, but it's not. Can I work out number 10?
No, let's do homework.
We're going to do number 19.
Well, that is on the homework.
Okay, let me give you the homework, get you started, and if you need help, I'll come to you. But numbers 13 to 27, odd. 13 to 27, odd. Oh, no, don't do 9. Yeah, start on number 13 to 27, odd. Excuse me, and then 36 to 39. And thank you. That's pages 353 to 350. Okay. Bye-bye, Swivl.